So in this online lecture, we are going to study about how we can just put one hydrogen and not further reduce the acid chloride or ester to all the way to alcohols. So how we can do that is this reagent over here. The reagent is dibol. Now we call it diisobutyl aluminum hydride. This is how it looks like. So diisobutyl group. So this is isobutyl group. Okay, and there are two of them. And then you have aluminium, and then you have the hydride. So since you have only one hydrogen over here, so you will be able to put only one hydrogen over here, so it can't be further reduced. So your reduction process will stop at aldehyde. So you do know how the things will proceed. The intermediate which you're going to get is it looks like this is a tetrahedral intermediate, which you're quite aware if you watch the previous parts of this video. This is a continuation session, and this is your intermediate. So what will happen here, this hydrogen will go ahead and make the attack. I will draw it for you for this one. Just one second. So this is your acid chloride, or let's say your ester. Let's go ahead and draw the ester, because this intermediate is for the ester. So what will happen? This hydrogen is electronegative. It will go ahead and make the attack. This is the nucleophile over here on this positive side. This bond will be pushed all the way up to oxygen. So oxygen will have this negative charge, and then this hydrogen will be attached here, right? So you have this intermediate which I've drawn over here for you. What would be the next step? So when you get this intermediate, it would be stable at minus 78 degrees Celsius. The temperature has to be very, very low. Else, so what will happen? This will not be stable. So this will push down, okay, and this will be kicked out, because you do know that OCH3 is a good living group. So you'll be left with this aldehyde over here, okay. So at this point, the temperature should be less, because and you want to make sure that if there is no other dibol left, the reagent left, because if there is other reagent left, that reagent, the hydrogen from that reagent will again attack on this carbon and carbon and reduce it further, but you want to stop it. So the temperature should be less, and you do want to make sure that there is no more reagent left in the solution. Let's move on next. So here we are going to learn about this thing where we are trying to form benzoic acid over here, okay. So what we have is this Grignard's reagent, okay. So there is a phenyl group attached to this MgBr, right? And then we have this carbon dioxide. Carbon dioxide is a linear molecule. It has two double bonds with oxygen, okay. So what will happen, as you know, this carbon is bonded to this two oxygen, so it is very, very electropositive. So what will happen, this will be acting as a nucleophile. As you do know, the R group in MgBr, in the Grignard's reagent, that is a nucleophile. It will go ahead and make the attack, and it will get attached over here to the carbon, and as a result, this bond will be pushed to the oxygen, right? And then this will be the oxygen bearing negative charge. So what will happen in the next step? So in the next step, it will grab the hydrogen from the hydronium ion, as we've done earlier also. It will get protonated, and it will form the OH bond over here. So what do we call this product is known as benzoic acid, okay. So